Okay, back to this little amp. So last night I hooked it up. Everything glowed, but I think I'm gonna risk it and just hook it up to a speaker and put a signal in it and see what happens. So let's first hook it up to a speaker. All right. And let's get a signal source into it. All right. Going to be using the signal generator. Make sure I have a sine wave somewhere around 1 kilohertz. And it is on. It is not on. Now it's on. And I'm going to turn the volume down. I'm going to turn the volume down. And I'm going to turn the amp off. And now we'll hook it up to the Variac. Turn the Variac all the way down. Alright. Now let's start by turning the Variac on and bringing the voltage up slowly. Well, you know what? I want to do that with this on. And the tone roughly in the middle, the volume down. And we'll bring up the voltage. The pilot light's starting to glow. Voltage now at 110. It's about where I want it. Pilot light is glowing. Okay. You heard that. I just turned it off with the Variac. So what happened was, as the amp started warming up, it had one hell of a hum or a buzz in there, and you could hear that through the speaker, and that's indicative of these bad electrolytic capacitors. Be interesting to look at that on the scope. Why not? Alright, so power's off. Let's go ahead and hook this up to a dummy load. So that's what you get with these old amps. These electrolytic capacitors last about 10 years. Even even new or modern electrolytics don't last. They have a limited lifespan too. And so basically they have to be channel 1. They have to be changed out every 10 years or so. And that's exactly what we're going to have to do on this amp. Alright, so you can use the old Beckman Industrial scope, which is what I used when I was in college. back in the early 90s, and even back then this thing was not exactly new. So this is a scope from the 80s, I think. Now let me get a calibration signal on this thing. We are times 10. Alright, I gotta get the scope working. I haven't trying to tinker with this old scope. Stand by. Okay, I got the scope working. So let's come down here, hook her up to the dummy load, and turn the amp back on, and pull this off the tripod. Okay. What are we seeing here? Oh my God, look at that. What on earth? Oh, look at that. Good gracious. I wonder if it changes with frequency. Yeah, I don't even have a signal in it yet. Oh, man. Okay, I'm playing with the volume control now, turning it up. Okay, this is the signal that I'm getting out. Across the 8 ohm dummy load. Oof. And got a 1 kilohertz. Okay, there it is. Okay, you can see it's being, I got about a 1 kilohertz sine wave being input, so it's being modulated. Oh my gosh. So that's pretty bad news there. So you can see as I change the frequency of the input sine wave, it's being modulated by whatever's happening in the amp. Now I'm just going to turn the signal generator off. I just did that, and there we go. Look at that. This is what the output looks like. It should be, you know, it should be just a steady, nice DC. Maybe a little bit of noise on it. A little bit of noise would be fine, but this is what we're looking at. I'm at 1 volt per division. I'm on times 1 on the probe. So 1, 2, 3, 4 volts peak to peak, whatever this signal is. And I suspect this is being caused by the bad electrolytics. So the first step is to change the electrolytics and see what we get. And once those are changed, if we still have a problem, then we just start tracing through the circuit and figuring out. We'll start out with the power supply, make sure everything's working there, then tracing the signal path and figure out where this horrible signal, this horrible distortion is coming from. So that's the first step. I didn't think this thing would work. Wonder if someone, when they bypass this capacitor, I don't know. See, so the problem is someone's been in here. I don't have a schematic for this, but somebody's been in here and they bypassed this electrolytic, put this new one on. I hope they hooked it up right. Alright. Let's go ahead and turn it off. Unplug it. We're going to put a new power cord on too. These old, if we get it working, these old power cords tend to fall apart. They become brittle. All right. Put this back on the tripod. And you know, there's really no good reason why I'm trying to get these old organ amps running again, other than just for the fun of it. It's just something I had laying around. I didn't want to invest any money. I just wanted a project to do. You always learn something new in virtually every project. And I just wanted something to do that was inexpensive, so I figured I'd get these going. And since I have two of them, make two mono blocks out of them. If they sound decent, they should. Boy, oh boy, that was one ugly signal. All right, well, now gotta discharge. Gotta discharge the. Look at that. Okay, gotta discharge the capacitor. And I know that the black lead is common. So go down there and connect the alligator clip to the common. And try to figure out, there we go. I'm just touching all the end of the three red leads, which is the ends of our, there we go, the ends of our 40, 40, and 20 microfarad. You know, I think someone, you know what someone did? They didn't, it's looking like they didn't really replace this big old leaky capacitor, but I'm just touching around everywhere. Make damn sure this thing is discharged. Although it's so leaky, it probably doesn't even hold a charge. Alright. It looks like what someone did is to put this new capacitor in parallel. Ooh, they did. So that's really stupid. I don't know if this is coming across on the camera. This is a good example of just dumbness. Okay. So whoever worked on this, I guess they felt this electrolytic was bad, and it probably was, so instead of just cutting this out of the circuit, which they should have, they put this new capacitor in parallel with it. You see we have the red coming out of the old electrolytic, continuing on to where it used to go, and then this green goes over to the new capacitor, so they've just paralleled it. Well, if this capacitor is leaking, that's essentially kind of like having a resistor in parallel with the capacitor. Putting another capacitor in parallel with this one is not going to stop the leakiness of this at all. This capacitor should have been snipped right here and cut out of the circuit, but it wasn't. I wonder if I do that and retest it, if that'll make a difference. So I'm going to cut. Okay, we still have this green one that goes up here. The green one is 40 microfarads, red up here is 80. This is only 2 capacitors, and this old can really has 3 of them in it, so I don't understand what they were trying to do here. Okay, well, gracious. They fed the red one. They did the same thing right here. Okay. And then there's a blue. And there's the black. Good. Okay. Now that thing is completely out of the circuit. And although the blue, see, I can't do this because the blue did not have a counterpart on this this red one. So what we can do, might as well just go ahead and go ahead and get rid of both of these capacitors, and I know they're just junk. I'm just going to keep them here for reference so I know what the values are. Alright, so now the electrolytics are out of the circuit. Okay. Yuck. You know, I'm going to have to solder new wires. Looks like there's a, well, yeah, I can't. Alright, I'm going to have to solder new wires on there. On the tube socket. So here's one red, here's another red, and there's a blue. And then here's our black. And we're going to need a new power cord. Also, I hate to do all this work and the thing still doesn't function right, but okay. Alright, well, let's start with, oh, there's that, I want to show you that resistor. The Muter, M-U-T-E-R company, Chicago, USA. I think that's a power resistor. It looks like some strips of carbon in there. Let me see if you get a close-up on that. You don't see one of these too often. Okay, so what we have is get a pointer here. This thing right here has a lead in and a lead coming out, and it looks like this is a piece of metal on the outside, but these are like strips of, it looks like taffy. And where's it coming from? Well, it's coming from one of the pins of the tube, and then the output goes to another pin of another tube. So it's coupling two tubes together. It's going to be a resistor. But the way it's made is really interesting. If I take the tubes out, I should be able to measure the resistance. So we'll take these tubes out. And let's see. How do I turn continuity off? There we are. So I'm just going to hold the ohm meter on there, and I get a value of 132 ohms. So that thing is some kind of it's a power resistor. 132 ohms. Cool. At least I know it works. Alright. So, first things first. I think I'll, for the time being, I'll leave. I'm gonna do this right. I think I'll put a new power cord. This thing is old and brittle. So go ahead and strip. Now, interestingly, this is not a polarized. This is not a polarized power. A plug, and the modern plugs are all polarized. Let me go get one. So this is a good thing to cover right now, because you can't just snip the old power cord and then hook a new one up any which way. It has to be hooked up very specifically, because the new power cords are polarized, meaning, I'll show you what that means in a minute, meaning that one prong is larger than the other. I always forget which one of them is hot, and I think it's the smallest one, and the larger one is grounded. Back at the panel box, this is connected to earth ground, and it is the line leading to the earth grounded, or the neutral line, they call it. It is this line that you want to, if you have, if one of these two is chassis grounded, you want to make sure that this one is the one that goes to the chassis ground. If there's no chassis ground, I don't think there would be in this amp, then we want to ensure whatever the ground, the circuit ground is inside the circuit here, is connected to the neutral as opposed to the hot. So the first thing we want to do is figure out which one of these goes to our circuit ground. How do we figure that out? Well, we kind of, I think I already know, because there's a black in this control. On this volume, this tone control, there's directly from one of these wires, there's a black wire running up to the tone control, and the other end goes out of the tone control over to a wire that goes to a tube. And so they wouldn't be running, I already know that that's going to be circuit ground. The other way to do it is follow, I don't know, no, that's not true. Okay, see, I'm talking out loud. This black wire right here that I cut, that went to the capacitor, was the neutral, or the ground on the capacitor, and then that is directly hooked up to the other. Yep, that's directly hooked up to the other power line. So the capacitor is actually going to dictate, because that's the power supply, that's going to dictate what the neutral or what the ground is. So the fact that this black wire that was hooked up to the capacitor goes directly down in here. Okay, let me pull this off the tripod. Alright. So here's this black wire that was hooked to the capacitor, and that goes down and directly connects to one of the two power cord lines. That's going to be the circuit ground, and that's the one that we want to hook up to the neutral, which is the larger prong, I think, if I remember right. One way to find out, I always have to do this, I always forget, and I'm gonna verify that. One way to find out is just to probe the AC voltage right in an outlet, and to put this on AC, volts AC, and I'm going to show you what I'm doing here. So I'm on volts AC, and I'm going to probe. Okay, you see it's 1 volt. Okay, good. Okay, there's 120. 12. Why am I getting 12? Not getting a good connection here. Trying to stick these probes into an outlet, and I'm just not able to get a good connection. There we go. Okay, what I'm doing right here is I'm directly across. Take this off the tripod. I'm directly across the two. Now that doesn't tell me anything yet. So I'm going right between the two prongs. Now what I want to do is I'm going to go between. Now I'm going to stick the ground one probe in the earth ground, which is the take this off. Show you. So one probe is going to go in the earth ground. This is not. This hole here is not live at all. This is completely just a straight copper wire right to earth, right to the ground rod that goes in the ground. And then I'm going to stick this probe in that one and then that one. The one where I get a 120 volt reading is the hot one, and the other one where I get a very low voltage reading, like a volt or two, that's going to be the neutral. and that's the one that I want to, and that whether it's the large or the small one is going to tell me which, which one it is. So let's do that. If I can show you this. No. Okay, now I'm going between the earth ground and the small. Why am I getting 11 volts? Okay, I'm getting 2 volts in the larger, and I'm not able to get in there. Oh, I know. Why? Nope. Not getting the readings. I get 120 across both. That's what I want. And then between the smaller of the two, I should be getting 120. I think it's because I'm in a power strip. I think I've got to go right into a wall outlet, which is what I'm going to do right now. You're not going to be able to see this. Yeah, okay. Yeah, perfect. Okay. Got it. Got it. Okay. For some reason I'm in a power strip and it was messing me up. So right in the wall outlet. Take this off. So in the wall outlet, I went from earth ground to the smaller one and I got 120 volts. And I went from earth ground to the larger one and got 1 volt. And that's what I'm looking for. So the larger one is the neutral. It's the one that's connected to the earth ground back at the panel box, and that's the one that I want to be connected to the circuit ground. So when we snip this thing, which I'm going to do right now, this is going to become our new power cord. What I want to do is I want to trace back the larger one, and that's got a little ridge on the side of it. And there's a little ridge, and then I'm going to strip this one because this one is going to be our connected to our circuit ground. So that's how we're gonna do that. All right. All right. Let me pull this other tube out so I can continue to work on this thing. Okay. Starting to get messy here. So the first thing I'm going to do before I do the capacitor is do the power. Let me cut the old power cord. Gone. Alright, now I want to do the splicing inside, and I'm going to leave the old cord on just for a few inches here and make the connection like that. Okay, so this one is, I know, is going to be my ground, my circuit ground. Okay. Now I'm going to run, there's a hole here with a grommet, and I'm hoping this grommet still works. first I want to run this through the hole, and then I have a kit of grommets. I can go find another one if this doesn't work, but I'm going to try to get this in here. Yeah, got it. So the grommet still worked. Okay, so I'm going to bring this around, and I want to connect these two together. I'm going to do an inline splice with shrink wrap. Okay. I'm going to do an inline splice like that with shrink wrap on it, and then I'm going to do the same for the other one, and then that'll be our new power cord. I like to put some strain relief on here in case this gets tugged, and one way to do that, it's kind of a cheesy, cheap ass crappy way, but it's just to tie a knot right there like that, and then pull it and just pull the grommet out, put a little tension on it, and there it is. There it is. I probably just made a little mini inductor in there, but I wouldn't do this if this was a high-end product, but I'm doing it on this one. Another way to do it, I'll show you. Another way I like to do it, strain relief, is use a zip tie. Again, I like to use things I have on hand. A couple of zip ties on here. One, get another one. And that just causes this to have a little thing to pull against the metal in the grommet. That'll do the trick. Now I've cut these, made these too long, so that's alright. Okay, so we're ready to do that splice, and then that one there. And I think I'll pick up on part 3 on this one. We'll get these get this power cord finished, and then start soldering some new wire for the new capacitor. And then I'll want to replace. I wonder what that's a. This is an electrolytic down here, and it is a 0.05 microfarad 400 volt. That could be one of our culprits too. See if I have that part. 0.05, 0.1. Got a bunch of 0.1s. 630 volt. Put a 0.05. Thought I had. I really thought I had 0.05, and that one's in the signal path too, and you never really, if at all possible, you don't want to use an electrolytic in the signal path. So I want to get the right value. I might have to order that. I really thought I had one. Oh well. Okay. Nope. Bummer. Alright. So I need to go order a 0.05, at least 400 volts DC. You know, I have 0.1s, and if you put two of them in series, I don't want to do that. That's just crummy. All right. Okay. Well, I'm gonna go ahead and order that one, and then this is in the signal path, I'm sure. I think. I don't have a schematic, so I can't tell. But either way, I'd like to get a poly type capacitor. I don't think I need an electrolytic for that. Although we definitely need electrolytics for the larger power supply capacitors. Where did that thing go? I've already lost my, oh, there it is. Okay, here's I've got the power supply cap. Alright. 0.05, 400 volts minimum. Okay, we'll end it here, and we'll pick up when I get that part in. Now, actually, we can go ahead and tomorrow night I'll finish up the power cord and get the power supply cap in there. Although, no, I'd like to use parts I have on hand. I'm going to change my mind here. I'm talking myself out of it. I'm just going to use a 0.1. I can't imagine it making a difference. 0.1, 630 volts. I just can't imagine that small a difference making any difference at all. Because, 0.05 is half that amount, but I'm just going to, I don't want to spend any money on this thing, so I'm just going to use 0.1. Alright, good deal. We'll pick up tomorrow night and go from there. Thanks for watching.